Hey guys, you're on GCSE iGCSE Revision. We're gonna go through vectors in geometry, and here are exam style questions. Alright, if you're ready, grab your pens, grab your notes, and let's get started. So you are given the rhombus ABCD, it's right there, and you're given that each side of the rhombus, because they are equal, is going to be 5 centimeters for each side. So dB equal to 4, so that's 4. And you need to find length of AC, okay? So that's why first let's connect 2 points A and C. This troy segment, okay? It's going to be diagonal, and you know the property for diagonal, they intersect so that they split in the point of intersection, let's say point K, on 2 equal halves, as well as this one, okay? So dk also equal to kb. How to figure out the length of AC? So AC is the full diagonal length, so if we figure out ck, which is half, so that's why we can figure out AC as well. So AC is going to be 2 of ck, and ck we can figure out from Pythagoras. So ck from Pythagoras is square root of, let's see, it's going to be 5 squared minus, that's 2, so dk is 2, so that's why it's going to be 5 squared minus 2 squared. Okay, so that's how it works, and we can arrive to the value of ck to be equal 25 minus 4 is square root of 21. So that's why up 21. Let's do it more precisely. Okay, and 2 of ck is going to be 2 square root of 21 in centimeters. So if you grab calculator and calculate, I'm sure you'll get answer in centimeters. So 2 times square root of 21. So what I've got, 9.17. So AC is around 9.17 centimeters. Okay, nothing about vectors until this point. Okay, find all angles of rhombus. Okay, we need to find all the angles for rhombus. No problem. So if we find this angle, let's say angle DCK, so we're gonna twice that, and that's how we can find the angle DCB. So that's why first, relating to this question B, so we've done A, and relating to question B, we can figure out angle DCB first, and that's going to be twice of the angle DCK. And how to figure out DCK? Using Trig's rules. All right, so DCK is going to be, DC is 5, opposite leg is 2. Okay, so we can use sine. So sine of the angle, let's mark as theta in degrees. It's better to write like this. Let it be angle theta in degrees, and sine theta is going to be equal to 2 over 5. So that's going to be 2 over 5. From where we can fix the angle theta itself. So angle theta, so my better. Okay, angle theta is sine minus 1, 2 over 5. So angle theta is sine minus 1 of 2 over 5. Okay, so hence we can calculate the angle theta itself. Use inverse function for sine 2 over 5. And we've got 23.6. So 23.6 degrees. So that's why angle DCB is going to be twice of theta. So angle DCB, maybe it's right below. So angle DCB is going to be twice of the angle theta. So that's why if we times 2 times, okay, we've got 47.16. So angle DCB is going to be 47.16 degrees. Okay, it's done. And next part, we need to find angle CDA. So the second step, CDA. Okay, so CDA is going to be twice of the angle CDK. So CDK. So that's why if we find angle CDK, we can find CDA by twice. We double that. Okay, so CDK is the angle which is here. And let's mark this angle as alpha. So how to find alpha? So using cosine. So cos of the angle alpha is going to be 2/5 in this case. 2/5. So that's why angle alpha is going to be the same. In the same way we can define angle theta. So as angle theta for alpha. Right now we taken cos -1 of 2/5. In this case we're taking cos instead. Okay, cos -1 of 2/5. Okay, so we've got the angle alpha is 66.42 degrees, and that's why angle CDA, finally, we can get it. CDA is just twice alpha. So that's why if we times that 2, we'll get 132 and 0.84 degrees. Okay, so that's one way, because there is an alternative way. For example, you found angle theta using sine, right? But you can figure out through the sum of all 4 angles. So I can also write this. So 2 theta plus 2 alpha. And if you twice that, you will get 360 because your rhombus is actually quadrilateral. So that's why if you times 2, you'll get 360. Or if you cancel, you can figure out that 2 alpha is going to be 180 minus 2 theta. That's finally, you should get the same answer. Okay, so let's check it. So 180 minus angle that we recently found, that was 2 theta, which is 47.16. 47.16. And you need to arrive to 132.84. As you can see, it works as well. This is the short track. Okay, so we completed A and B, and let's move next. So we are in C right now. You need to calculate the area of rhombus, okay? Rhombus is made of actually 2 triangles. If you consider the first triangle, in this case, we just double the area, and that's how we can get the area of the whole rhombus. So 2 times the area of the triangle. Let's put the area sign. So area sign for the triangle C, D, and B, okay? So how to figure out? You remember that before we found the height, okay? So we found the height more precisely, okay? For some reason it doesn't work from point C. Oh. Okay, now I got it. Okay, so we found CK, right? That was K point here. And if you remember on the previous step, so AC, this half, but CK is square root of 21. So CK is square root of 21. So that's why we can simply use the formula for the triangle. So 2 times area of triangle is CK, which is height, square root of 21, times the base, which is 4, and 1/2 of that. So we can cancel, and we stay with 4 square root of 21. That's the area for the rhombus. If you like, you can calculate that. So area of the rhombus, RH, is going to be 4 square root of 21. But I'm pretty sure you can use your calculator. So I've got 18.33. 33 centimeters squared. Okay, so we've done up to C, and the rest part will be dedicated to vectors. Okay, so